So you'll see some similarities between, I guess it was, yeah, with divisibility rules last week, and what we're going to do today. Definitely a lesson that's big on finding patterns and applying those to get the final answer. Right. So one of the things that we did was found two numbers that multiply to the number on the top. So two numbers that multiply to 12 and add to this number on the bottom. So you can either unmute yourself and shout it out, or you can put it in the chat. But what two numbers multiply to 12 and add to 7? All right, exactly. 3 and 4. And again, just to reiterate, it doesn't matter which side you put the 3 on and which side you put the 4 on. And if you didn't see that it was 3 and 4, again, one option is to write the factor pairs, 1 and 12. We know they both have to be positive because they multiply to a positive and add to a positive. So you could look at your factor pairs, and 12 is one that we worked with quite a bit. So there are the factor pairs. Again, if you saw it right away, you probably didn't need to do the factor pairs, but this is always an option. All right, two numbers that multiply to 9 and add to -6. Excellent, excellent. So in this case, they add to a negative but multiply to a positive. So both numbers are negative. And in this case, both numbers are -3. All right, how about this next one? Multiply to 18, add to -9. Yeah, -6 and -3, or -3 and -6. Again, order doesn't matter. And I guess I didn't show it with the 9, but I'll show it here with the 18. Again, you can use the factor pairs. They are both going to be negative. And I think one common mistake is to pick the second factor pair because you see the -9 here and the -9 there. This value does not have to be one of the factors. In fact, it cannot be one of the factors. All right, last one. Two numbers that multiply to +16 and add to -8. And pretty soon I'll quit writing the multiplication symbol and the addition symbol in the X's. And -4 and -4 are correct. Excellent. So we're going to actually extend this idea now with polynomials. So if I multiplied out this binomial expression, this product of two binomials, I would get x squared plus 5x plus 6. And I'm actually going to multiply it out because it's going to really show the connection between that little x puzzle that we've been doing. So if I use FOIL, I get x times x, which is x squared, x times 3, which is 3x, 2 times x, which is 2x, and 2 times 3, which is 6. And if I combine my like terms, I get x squared plus 5x plus 6. So just to verify that. So when we want to write the factored form, we want to take this expression and write it like this. So here's where that x puzzle comes in. We want to find two numbers that multiply to that end value and add to that middle value. And I think you can maybe see why looking at the FOIL, right? We multiplied our two numbers to get this last term. We added the two numbers because they formed our like terms. So it is going to be 2 and 3. And the factored form, just like it is in the beginning of the problem, x plus 2, x plus 3. All right. So that's the idea. That's the process. We want to find two numbers that multiply to 36 and add to 13. So they're multiplying to a positive value and adding to a positive value. So they both have to be positive. And again, if you're not sure what those numbers are, make a list. Here are my factors, 1 and 36. They don't add to 13 though. And I always would do the factor pairs, go with numbers that multiply to 36 and see if they add to 13. 2 and 18, that doesn't add to 13. 3 and 12, that does not add to 13, but we've got to be close because that adds to 15. My next pair, 4 and 9, they do add to 13. So one thing I want to caution against, this isn't my answer. The X part is not my answer. It just helps me to get to my answer. My answer is the binomials my answer is the binomials x plus 4 and x plus 9. Okay, the x is just a method, and there are other methods that you can use that get us to that answer. And again, listing out the factor pairs is one way that might help you to get to the answer. You don't have to do it that way. But if you do decide to do it this way, where you show the factor pairs, always start with 1 and then try 2 and then try 3 and work your way down systematically so that you don't miss the correct factor pairs. All right, go ahead and try this one. Shoot me an answer in the chat when you think you know the two numbers that multiply to 28 and add to 11. All right. 3 quick answers there. That's awesome. 7 and 4 or 4 and 7. Again, the order doesn't matter. You could write it as x plus 4 and then x plus 7. That would be equivalent and correct. So good. This is one, I'll be honest, growing up, anytime I could relate things to sports, it helped me. So anytime there was a multiple of 7, I always thought about football and touchdowns and extra points. So that's the way I remember some of my multiplication facts. All right, so the first set of examples we did, both A and B were positive. Now we're going to look what happens when the number that we have to add to is negative. So now we want two numbers that multiply to positive 18 and add to negative 11, similar to the last, I think the last 3 examples we did right at the beginning. Again, when you think you have it, go ahead and put it in the chat. Excellent. -2 and -9. X minus 2, x minus 9 is my factored form. Another one here, two numbers that multiply to 15 and add to -8. Again, we know to multiply to a positive value, our numbers have to have the same sign. And if they're going to add to a negative, that means they both have to be negative. So if you're not sure, start with -1 and -15. 2 isn't going to work. -3 and -5 add to -8. Yeah. Oof. Let's try that again. There we go. All right. So the other thing that could happen, we could have to find numbers that multiply to something that's negative. So two numbers that multiply to -6 and add to +5. Excellent. All right. So this is one of the most missed problems um, of this type. And the reason is students see that 6 and they think, oh, 3 and 2 because that's 5. But because it's -6, one number has to be positive, the other has to be negative. And if we look here, it has to add to a +5. So the larger number has to be the positive one. So -1 and 6 would be a possibility. And that does add to +5. So the one thing with these factoring problems for polynomials, there is definitely one right combination. If you tried 2 and 3, -2 and +3, definitely multiply to -6, but they don't add to 5, they add to 1. So just be careful with that. All right, a couple more examples. Multiply to -14, add to -5. Again, feel free to share in the chat or shout out what you think. Yep. So 2 and -7. And so generally, I whatever number I put here, that's the factor I put first. Again, it doesn't matter what order they go in because multiplication order does not change our answer when all we're doing is multiplying. Last example on this page, multiply to -16, add to +6. And -2 and 8. Excellent. All right. We must have done the try now together. That's okay. If you remember from multiplying binomials, we had a case where if we multiplied two things, we got the first thing squared minus the second thing squared. And what happened, or the way that happened, was when we had a plus b and a minus b. So here, with factoring, if you notice that you only have two terms, and you're subtracting in between, this is a special case. Using that X method will still work. But what you would have to do is think of this kind of in a little bit different way. This is like x squared plus 0x minus 9. So you could think of it as two numbers that multiply to -9 and add to 0. And the only way two numbers can add to 0 is if they are exactly the opposite. So, find what number, when I multiply it by itself, gives me 9. I'll give you a hint, it's 3. So if we only have two terms and there's subtraction between, and it can be factored, you're going to get something plus a value and something minus a value. And it's that. So this is going to be the same. These are just going to have opposite signs. Little more difficult when we have a number in front of the x squared. But with the difference of squares, it makes it somewhat easier. I know I need to find two numbers that multiply to 4, or a number times itself that multiplies to 4. And for the last part, a number times itself that multiplies to 81. So the X method doesn't work when there's a number in front of the X squared. So with these difference of squares, if there's a number in front of the X squared, you'll have to kind of reason it through. All right, so I want you to try these two on your own. I'm going to give you a couple of minutes. Some of you may be done by the time I get the timer set up, but that's okay. And then we'll take a look at answers. All right. So if we factor these, x plus 6, x minus 6. Again, you could also write it x minus 6, x plus 6. That would be fine. And this one, 3x minus 10, 3x plus 10, right? So a number times itself that gives you 9, that's where the 3 comes from. A number times itself that gives you 100, that's where the 10 comes from. All right, one other thing that might be helpful as you're doing these problems, I'm going to put a little chart here. Come on. There we go. So larger factor, smaller factor. So if our polynomial is x squared plus bx plus c, if it's all addition, our larger factor is going to be positive, our smaller factor is going to be positive. If we have x squared minus bx plus c, our larger factor is negative, our smaller factor is also negative. If we get x squared minus bx minus c, our larger factor is negative, our smaller factor is positive. And the last option, the last thing that could happen is we could get x squared plus bx minus c, where our larger factor would be positive and our smaller factor would be negative. So just a good thing to, a good reference as you're working through these. Any questions?